In lesson 21, we are going to learn about ellipses. Ellipses is another conic section. The first one that we learned about were parabolas. The definition of an ellipse is that it is the set of all points in the plane whose distance from distinct fixed points, which are called foci, is constant. So when we first learned about parabolas, a parabola only had one focus. An ellipse has two foci. It also has two vertices, and the chord that joins the vertices is called the major axis. And the midpoint of that chord is the center of the ellipse. And we can use the concept of eccentricity to measure the overall ovalness, how round an ellipse is. So an ellipse can go one of two ways. It can run with its major axis parallel to the x-axis, or its major axis parallel to the y-axis. And here we have two rows in this table for both of those. We're going to start with an ellipse whose major axis is parallel to the x-axis. So if its major axis is parallel to the x-axis, that means that the ellipse runs horizontally. And so it would look something like this, where its vertices are here on the ends of it. I'll call these points V1 and V2. So the major axis is this chord right there, and you can see that that blue chord that I just drew is parallel with the x-axis. The foci of the ellipse are on the inside of the ellipse. I'll call this one F1, and I will call this F2. The center of the ellipse is in the middle, and we will call that point HK. So we're calling the center of our ellipse HK. So there's a few pieces of information here at the top of this table that will help us find the coordinates of our foci and our vertices. Little a represents the distance from the center to a vertex. So little a is this distance right here. So we can see that then that vertex on the right would have the coordinate h plus a, comma, k. I'm adding a units to the x coordinate of the center because it moves a units to the right, and it's staying on the same horizontal line, so the y coordinate is still k. On the other hand, this distance here is also a to find v1, but that moves a units to the left. So these are the two coordinates for those two vertices. In one of them we add a, and in the other one we subtract a, because a represents the distance from the center to a vertex. The second bullet point here tells us that c represents the distance from the center to a foci. And so this distance here is represented by c, and so we moved c units to the right from the center. So the coordinate for that would be h plus c, comma, k. I am adding c units because we're pushing c units to the right. And then to find the equation, or rather the coordinates of the other focus, I would subtract c units from the x coordinate of the vertex, moving c units to the left. And so those are our 2 points there. The general equation of an ellipse whose major axis is parallel to the x-axis is given here. X minus h squared divided by a squared plus y minus k squared divided by b squared, and that's all equal to 1. This is the standard form of the equation of an ellipse. Notice that a is under the x term. The third bullet point here tells us that a is always larger than b, and b is always larger than c. So if a is bigger than b, a squared is bigger than b squared. And so a squared is larger. A squared is larger. That's how you can tell from looking at the equation which way the ellipse runs. The larger number is always under the variable of which the major axis is parallel to. So here, the larger number, a squared, is under the x. We know the major axis is parallel to the x-axis. The last bullet point, b squared equal to a squared minus c squared, that equation we will use when we start looking at some examples and we're finding the equation of some ellipses. For our second graph, when the major axis is parallel to the y-axis, we will sketch what that looks like. That would look something like this, where now the ellipse is running up and down. The vertices of this ellipse would now be at the top and the bottom, so I'll label that V1 and V2. The center is still right there in the middle. I'll call that the point HK. The foci are still inside of the parabola. The foci are always closer to the center than the vertices are. That's why C is smaller than A. So in this case, now the first vertex, let's talk about V1, that is A units above the center. And so that coordinate would be H comma K plus A. I'm adding A now to the Y coordinate of the center since it moves A units up. The second vertex would be H comma K minus A. I'm talking about V2 now. Call that V2. That is A units below the center. For the foci, the distance between the center and the focus is C. So let's call this F1, and it doesn't matter which one we call F1 or which one we call F2. That's irrelevant. F1 is C units above the center. So the X coordinate will stay the same, and I will add C to the Y coordinate. F2 is C units below the center. So the X coordinate will stay the same, and I will subtract C units from the Y coordinate. Notice in the equation here, A squared is still larger. A squared is always the largest. That's what our third bullet point there tells us. Here, A squared is larger, and notice that A squared is under the term with the Y variable. And so because the A is under the Y, that tells us that the major axis is parallel to the Y axis, which we can see that it is. The major axis is this line here that I'm drawing in light blue that goes through the vertices, the center, and the foci, and that is parallel to the y-axis. The last thing I want to say before we look at some examples is you may be wondering, what's the purpose of B? It seems like we didn't use the little b for anything. What little b does tell us is it tells us these 2 points here. So that's not along the major axis. We call that the minor axis, but it tells us that, as you can see, this point up here that is above the center. And so the coordinate for that point would be H comma K plus B. The coordinate for this point below the center would be H comma K minus B. So B tells us how far above and below the center those 2 points are. On the other hand, if the ellipse runs parallel to the y-axis, little b will give us the coordinates for these 2 points on the left and the right of the center, where we would add b to the x coordinate of the center and subtract b from the x coordinate of the center to find the coordinates of those 2 points.